Thanks everyone for joining us for our brief session. Today we're going to be talking about orchestrating Airbyte in Google Cloud Platform. I am super excited to dive in. We only have 10 minutes, so we're going to be flying through this really quickly. With that, let me kick it off with an agenda. First off, got to talk about us, who we are, where we work, what we're doing. Once we get that all out of the way, we'll dive into the good stuff. I'll pass the mic over to my colleagues, and they will dive into developing custom scripts on top of Airbyte, why we're doing that, the problems it solves, etc. How we deploy and orchestrate Airbyte connectors within Google Cloud, and then on the back end, how we build resilient data pipelines to get the data from our connections into users' hands. So very briefly about us, we work at Pliancy. Pliancy is a tech-enabled services company really focusing in on the capital management, life science areas, industries, whatever you want to call it. We come in and we solve all technical problems for our clients, right? Whether it's endpoint or network, security, cloud orchestration, et cetera, et cetera, et cetera. We really take a white glove approach to that. And seeing as how everything is SaaS nowadays and everything is kind of best of breed, we find ourselves utilizing that data more and more and more. And that's really what we're talking about today. All right, so who are we as individuals? Hi, my name is Blair. I run the data platform team. I really am just here to make sure that these smart folks get what they need so they can keep doing what they're doing. Speaking of smart folks, I got Yash here with me. He's our data engineer, and Zach, our data cloud architect, and they will be doing the nuts and bolts and nitty gritty today. Last thing before we get there, why are we doing this? Why did we orchestrate it this way? Why did we choose these tools? I mentioned that we're really heavily invested in SaaS, and so are our clients, and I'm sure so are most of you, which is why we're here using Airbyte. We have found that, again, like I said, 99.9% of all of our data is in SaaS, and we needed a robust, resilient, manageable way to access multiple tenants from each of these applications. And so we landed on Airbyte. From there, we needed to orchestrate it. We needed to manage it. We needed to be able to, code against it in a performant way. And we landed on Terraform, as does pretty much every other software engineering team, right? Once we get the data in, and again, I'll let the team talk about that in detail here in a second. We then access it via Looker for more, stereotypical BI use cases, and then pipe that data back into our platform itself. That is our product that we offer to our customers in order to utilize that data and make informed decisions, take action against data, remediate issues, et cetera, et cetera. All right, we got that out of the way. Now I will pass the mic over to Yash. Yash, take it away, my man.
Thank you, Blair. Hi, everyone. Today, I'm going to discuss my journey of creating Airbyte custom connectors. To date, our team has contributed several connectors. Timely and Zenefits are one. IT Glue and SentinelOne will be available soon. We have multiple internal connectors running in our production environment as well. We are thrilled to have the opportunity to contribute to open source and get powerful tools to help our internal needs as well. Here's our process for creating a brand new connector. First, we meet with the stakeholders to determine the objective and needs. After researching the API endpoints for the connectors and scopes, we add a simple Python script using request.get methods. As most of our data engineers watching will know, this isn't a standard Airbyte development procedure. Why have we chosen a non-standard procedure for building a connector? We had excluded the Python scripting in the first connector we built, but ran into issues with authentication into SaaS apps, tracking those issues down, and schema definition. Using the script before handing off to Airbyte gives us a detailed schema of records and connection logs. This helps the execution of Airbyte connector in a simple and more effective fashion, allowing Airbyte to concentrate on important things like spec, check, discover, and read jobs. Let's look at our DAGs now. To work with Cloud Composer, Google's hosted Apache Airflow servers, we needed a standardized and replicable environment. It was obvious to us that infrastructure as a code would be the solution, and Terraform was an easy choice. Once deployed in Terraform, it was straightforward to set up the necessary connections and begin DAG development. We know our development environment will behave consistently in production thanks to everything being deployed and managed via Terraform and our CI/CD pipeline. Setting up Cloud Composer connection for Airbyte was simple, but finding the host IP and port of the Airbyte server connection on the Kubernetes engine cluster may be the difficult part. Rather than juggling schedules between Airbyte and other services, we can do it all in one place with one simple Python file within the Cloud Composer. As an example, I have a small DAG for a Timely connector, which emits the records from the Timely API to GCS via Airbyte. Once task 1 of the DAG is complete, it will trigger the next task via Dataform. Dataform is Google Cloud's data modeling tool, which is now available in public preview as a part of BigQuery services. Dataform will provide the instructions for BigQuery to interpret the data from cloud storage. All of this is done via one simple DAG. I would like to pass it on to Zach for further details. Thank you.
Thanks, Yash. We wanted our data stack at Pliancy to be highly available and resilient to change, and we knew we had to establish some core goals to achieve this. First, that all external source data must first be stored as close to the raw output as possible, removing bias from the ingestion method. Second, that column references and paths should be carried downstream as far as possible to promote clear column lineage. And third, to have a flexible interpretation structure that can adapt quickly to changing conditions. When choosing solutions, we let the data format guide us. We are working almost exclusively with SaaS apps and RESTful APIs, so bringing raw JSON responses into Google Cloud Storage was the most straightforward approach. This covers our first goal of removing bias and keeping our raw data authentic. A mix of design and solutions covers our second and third goals. We use Dataform to establish each of our data layers with clear separation, while BigQuery gives us a flexible interpretation engine where we can rebuild our data layers quickly. We wanted to share with you today what this type of flexibility looks like and the options you can give yourself in pipeline design. We've established that our raw JSON lands in cloud storage. I'll note here that a good feature is we can apply Hive partitioning syntax into our URI paths, allowing for partition queries when reading from GCS. Next, we establish our raw layer by creating external table definitions on our cloud storage. Here, we already get some flexibility on schema definitions as we have options to either 1, rely on BigQuery's schema auto-detect feature, 2, declare our own schema in the create table syntax, or 3, keep the Airbyte data JSON array and use BigQuery JSON functions in a secondary view before proceeding. These options give us control over the interpretation of the external system schema that does not hold up our ingestion. Last, we establish our semi-structured layer by deduplicating our raw definition. I'll provide here our chosen syntax using a window function and prioritizing the most recent records emitted by Airbyte. As Dataform can perform incremental materialization, we also gain the option to handle new data incrementally or refresh the latest full response. This structure has allowed us to pivot quickly and address schema changes, data source availability, and data quality issues with minimal disruption on our end and minimal risk of data loss. And with that, I'll pass it back over to Blair.
Okay, that was a lot. Really appreciate your time. Really appreciate you guys jumping in here. Please, please, please hit us up on LinkedIn. We are all very active on the Airbyte Slack. If you have questions, you want to talk about this in detail, 10 minutes is definitely not enough time to get into all this stuff. So please hit us up. We'd love to chat about this with everybody. And with that, I appreciate your time. Thank you very much. Have a good rest of your conference, everyone.